This is the intro to power video, but we're going to preface this with this question. Which is more work, walking up a flight of stairs or running up a flight of stairs? Alright, we're going to assume that both of these are done at a constant speed. Just walking is a slower constant speed than the running. So, first question, which case are you more tired? This is one way to kind of think about it. Odds are you're thinking running up the stairs is going to make me more tired, but does that actually make you do more work? So let's think about what actually is changing when you go from walking to running. Okay, so let's look at the two situations. What is the vertical force required to make you walk up the flight of stairs? You should be saying your weight, okay, because it's moving you up, and if you're moving at a constant walking speed, the force needed to move you up cancels out your weight, okay? If you're running up a flight of stairs, as long as you run at a constant speed, that's also the same thing as your weight, okay? Running doesn't change your weight. The distance, as long as we're going up the same height of stairs, the same flight. So, height of the stairs is the distance for walking, as well as the distance for running. Now let's think about how long this takes. Walking up a flight of stairs will take more time, alright? It's slower. Running up a flight of stairs will take less time. Okay, so now that we've thought about this, if we look at your work equation, work equals force times distance, does that data table tell you that you're going to have different amounts of work? Okay, if you have same weight for both, that's the same F. If you have the same height for both, that's the same D. So you should be saying no. Same amount of work whether you're walking upstairs or running upstairs. Okay? So, power. In physics, power is the rate at which work is done. This is what changes when you go from walking to running. Because power is your work divided by the time it takes. Okay, you can look at this equation two different ways. There's power equals work divided by time, or the one we're going to focus on today is power is equal to the force times the distance divided by the time it takes to do that. Okay, because force times distance is the same thing as your W. So, power's units, if you think about it, if you have it broken down like this, you should be able to pick out the units of all of the pieces. So what are the units for force? That's a Newton. What are the units for distance? That's a meter. The units for time, you should say, is a second. So, this is our first version of units. You have a Newton meter per second. Okay? Now, we've also learned that a Newton meter has another name. Okay, Newton meter is also known as a joule. So you could write this as joules per second. That's the second version of units for power. There's also the fact that a joule per second has its own name, the watt. Okay, so there's the third unit for power. And one other unit for power, 750 watts is equal to 1 horsepower. Okay? Hopefully that you'll notice that is our fourth possible unit for power. Okay? This unit here you'll probably see the most often is the watt. But I would also know joule per second. But hint hint, for today, your assignment, you want to know all four of these. So, a sample problem for power. How much power is needed to move an object with a force of 100 newtons across a 4-meter table in 5 seconds? Alright. So, first thing is list your knowns and unknowns. So if you go through, underline the numbers that you see. These are your knowns. So you know your force is 100 newtons. You know that your distance is 4 meters, and you know the time is 5 seconds. Alright, your unknown is what the question's actually asking for, and that's power. So next thing is choosing your equation. That's just our basic power equation. You don't need to rearrange it because the piece you're missing is the P, so it's already set up on the equal side. So plug in your knowns where they belong. So you have 100 newtons plugged in for F, 4 meters plugged in for D, and 5 seconds plugged in for T. Okay? So solve, and don't forget your units. If you multiply your 100 by 4, that becomes 400, and you still have your 5 that you need to divide by. 400 divided by 5 gives you a final number of 80. Then your units could be 80 watts, 80 joules per second, or 80 newton meters per second. The only one that doesn't work here is the horsepowers, because that would require a conversion because it's 750 watts per 1 horsepower. Okay? So that's the end of this one. Make sure that you complete the online assignment that goes with the Intro to Power video. Don't forget, you also have to do the work and direction video today as well.